In modern construction, we are told that sealing a house completely airtight is the ultimate goal for energy efficiency. But as a structural engineer, I'm seeing a dangerous trend. When you trap air perfectly inside a building envelope, you aren't just saving on utility bills, you might be creating a ticking structural time bomb. Here is what happens when building science goes too far. Welcome back to Next Gen Home Builders. Over the last 2 decades, building codes have aggressively pushed for tighter and tighter structural envelopes. We use advanced house wraps, expanding spray foams, and high-performance multi-pane windows to eliminate every single microscopic draft. The logic seems flawless. Seal the cracks, stop the conditioned air from escaping, and drop the home's energy consumption to near zero. But there is a massive difference between an energy-efficient home and a healthy, durable structure. Historically, houses were built to breathe. Older homes had natural passive air exchange through small gaps in the framing, windows, and cladding. While that made them drafty and expensive to heat, it had a massive hidden benefit. It allowed the building skeleton to dry out. When we completely delete those minor draft paths without understanding the physics of air pressure, we fundamentally alter how a building behaves. We transition a home from an open, adaptive ecosystem into a hyper-sealed plastic container. And when you trap a dynamic environment inside an unyielding container, physics always wins. The real trouble starts with an invisible metric that most homeowners completely ignore until it's far too late. When a home is built too airtight, the immediate consequence isn't structural failure. It's the rapid degradation of the indoor air quality. Think about everything that happens inside a house. Every time someone takes a hot shower, boils water on the stove, washes clothes, or even breathes, gallons of moisture are pumped directly into the air. In a traditional home, that moisture dissipates. In a hyper-sealed modern home, that moisture has absolutely nowhere to go. It hangs in the atmosphere, driving the indoor relative humidity up into a dangerous zone. But it isn't just water vapor. Every piece of modern furniture, engineered flooring, and paint off-gases volatile organic compounds, or VOCs. In a house without natural air infiltration, these chemical gases, along with carbon dioxide and everyday allergens, accumulate into highly concentrated, toxic pockets. You aren't just living in a highly insulated home. You are living inside a stagnant, pressurized bubble. The air becomes heavy, the windows start to sweat, and the indoor environment becomes an ideal breeding ground for microscopic issues. But as alarming as the air quality is, what this trapped moisture does to the actual structural framing is far worse. To understand the structural threat, we have to look at the physics of vapor drive. Moisture naturally wants to move from an area of high concentration to an area of low concentration. In the winter, warm, humid air inside a tightly sealed home desperately tries to push its way outward through the walls toward the dry exterior air. If there is even a single microscopic tear in your interior vapor barrier, the indoor air pressure will force moisture directly into that tiny gap. Once that humid air enters the wall cavity and hits the cold, exterior plywood sheathing, it reaches its dew point and instantly condenses into liquid water. In a traditional house, a steady flow of structural air leakage would quickly dry that cavity out. But in a hyper-airtight home, the wall is wrapped so tightly in plastic and foam that the trapped liquid water can never evaporate. It sits directly against your load-bearing timber studs and oriented strand board sheathing, completely hidden from view. Month after month, this dark, sealed cavity undergoes wood rot and structural decay. The home looks completely pristine on the outside, while its primary structural skeleton is quietly turning into mush. This mechanical failure is what the engineering community calls sick building syndrome. The structure is so sealed that it cannot shed its toxins or its wetness. What makes this problem worse is the pressure dynamics caused by everyday household appliances. When you turn on a powerful kitchen range hood, a clothes dryer, or a bathroom exhaust fan, they aggressively pump air out of the house. In an airtight home, that displaced air cannot be easily replaced. The house drops into a state of severe negative pressure, creating a literal vacuum. This vacuum will find air wherever it can. It can pull highly dangerous carbon monoxide down through a water heater flue, or suck toxic radon gas straight up through the concrete foundation cracks from the soil below. By trying to build an impenetrable fortress against the outdoor elements, we accidentally create a vacuum loop that drags dangerous elements directly into our living spaces. This is the ultimate paradox of modern residential engineering. A home built too tight can actively work to destroy itself and poison its occupants. So, what is the solution? Do we abandon energy efficiency and go back to building leaky, drafty houses? Absolutely not. The answer lies in a golden rule of modern building science. Build tight, but ventilate right. If you are going to engineer an airtight building envelope, you must intentionally engineer a mechanical respiratory system to go with it. You cannot rely on people opening windows. You must install a dedicated energy recovery ventilator, or ERV. An ERV acts as the mechanical lungs of the house. It continuously exhausts the stale, humid indoor air and replaces it with fresh, filtered outdoor air. The magic happens inside the core of the unit, where the outgoing air pre-warms or pre-cools the incoming air without ever mixing the two streams. This gives you the best of both worlds: maximum energy efficiency and pristine indoor air quality. True structural longevity is never about achieving a single metric like airtightness at the absolute expense of building physics. It is about understanding that a home must balance insulation with continuous, controlled air exchange to survive the test of time. A home shouldn't be engineered like a static plastic bag. It has to be designed as a living, breathing system that handles air, pressure, and moisture with absolute precision. When you balance insulation with proper mechanical ventilation, you protect both the structural skeleton and the people living inside it. If you want to keep learning the uncompromised engineering truths behind modern construction, smash that like button and subscribe to the Next Gen Home Builders channel to help us push this video through the algorithm. Don't forget to turn on all notifications so you never miss a deep dive. Drop a comment below. Do you think modern homes are being built too tight? Thanks for watching, keep your tolerances tight, and I'll see you in the next analysis.